Hi guys, I'm back again. Let's go ahead and jump right into to example 1. So throughout example 1, I'm supposed to have you guys write your thoughts on personal whiteboards or on scrap paper. Um, you guys can go ahead and do that for yourselves, but we're just going to go ahead and go through the example. Um, we want to express the following statement using symbolic language. A whole number has the property that when the square of half the number is subtracted from 5 times the number, we get the number itself. That's crazy. That's even confusing to me, okay? So, pardon me, I'm dealing with a little bit of my allergies right now. You'll have to forgive me. So if we do the first step and hold up your personal whiteboards, let's see. First, we define the variable. Let x be the whole number. Using x to represent the whole number, write the square of half the number. So x over 2 squared. So half the number would be x over 2 squared. Or you could write 1/2 times x squared. Or you could write x squared over 4. Because if you square 1/2, it's going to be the 2 is going to become a 4, because 2 times 2 is 4. That's the square of 2. Or 1/4 times x squared. All of these would be correct. They'd give us the same answer. Okay. The square of half the number, if you write the entire statement, a whole number has the property that when the square of half the number is subtracted from 5 times the number, we get the number itself. That's a very hard statement, so we're going to break it down. A whole number has the property. Property means something about it. That when the square, meaning, a number plus or times 2, the square of half, meaning 1/2 the number, x, is subtracted, so the whole number is x, remember, subtracted 5 times, that's minus 5 minus 5 minus 5, 5 times. The number, we get the number itself. So, let's take a look at that. 5x, 5 times x, minus x over 2, that's half the number, squared, equals x. That will equal the number itself. When a number, so x, is subtracted from, so minus x minus itself, the difference is 0. For that reason, the equation above can be written as 5x minus x over 2, so that's 1/2 x, squared, minus x, your answer is 0. Think about why that is. Think about why that is. If you are minusing 1x squared, you're actually minusing the number. So that makes it 0. Excuse me, again. Throughout example 2, I'm going to have you guys, well, I'm not going to have you guys write your personal thoughts, but if you have a piece of paper handy, it might be a good idea to go ahead and write stuff down. Okay, we want to express the following statement using symbolic language. Paulo has a certain amount of money. If he spends, so a certain amount of money would probably be x. If he spends $6, then he has 1/4 the original amount of money left. What is the first thing that must be done before we express this situation using symbols. We need to define our variables. That is, we must decide what symbol to use and state what it is going to represent. We could use x, but suppose we decide to use the symbol x, we will let x be the number of dollars Paulo had originally. How do we show Paulo spending $6 using symbols? To show Paulo spent $6, we write x minus 6. How do we express he has 1/4 of the original amount, 1/4? We can express it as 1/4 of x. So remember, of means to multiply. So we say this as 1/4 of x. It means 1/4 times x. Put the parts together to express the following. Paulo has a certain amount of money. If he spends $6, then he has 1/4 of the original amount left, or 1/4 of x. Use x to represent the amount of money Paulo originally had. X minus 6 equals 1/4 of x. Very good. So, we can also say that $6 plus what he has left is equal to the amount of money he has now. For example, in symbols, x equals 1/4 of x plus 6. All right. Example 3. We want to write the following statement using symbolic language. When a fraction of 57 is taken away from 57, what remains exceeds 2/3 of 57 by 4. So the fraction could be x. The first step is to clearly state what we want our symbol to represent. If we choose the letter x, then we would say let x be the fraction of 57, which is what we said. Our fraction is x. Because that is the number that is known to us in the written statement. It is acceptable to use any letter to represent the unknown number, but regardless of which letter we use to symbolize the unknown number, we must clearly state what it means. This is called defining our variables. Defining our variables. Remember that statement. The hardest part of transcription is figuring out exactly how to write the statement so that it accurately represents the symbols. So it's accurately represented in symbols, sorry. So basically, write it correctly so that it equals the thing you want it to equal. Begin with the first part of the statement. When a fraction of 57 is taken away from 57, how can we capture that statement? Well, we can say 57 minus x, because the fraction is taken away from it. Whenever something's taken away from something, it's always the second number in your subtraction problem. How do we rewrite 2/3 of 57? Well, if we are trying to find out 2/3 of 57, it would be 2/3 times 57. Would it be accurate to write 57 minus x equals 2/3 times 57? No. Because we are told what remains exceeds is more than 2/3 of 57 by 4. So, where does 4 belong? What remains exceeds 2/3 of 57 by 4. So, the word exceeds means it's more than. So, alligator always eats the big number. That means greater than, this is less than, or sorry, excuse me. This is less than, greater than. Okay, I'm running out of time, so I'm going to go ahead and stop the video here, and I'll see you in the next one.